Hello students, welcome back. Now we are going to talk about up/down counter. That means a single counter which can count in both the directions. So in this video, we are going to talk about the functionality of the up-down counter. How can we design it using the behavioral style, and we are going to implement it in Verilog. So first of all, the brief summary of up-down counters. Normally, all the counting processes are done in the upward direction. That means we just increase the count value. We can configure them to count in the reverse direction as well. We had seen that in our previous video that we were able to count from 15 to 0 as well by just changing the triggering edge of the clock. An additional control variable can be added, and then we can control the direction of count, whether we want to count up or down. So if I have a 4-bit up-down counter, in the upward direction it is going to count from 0 to 15, and in the downward direction it is going to count from 15 to 0. So here we have up counting. We are moving upstairs, that means the count values are going up. On the other hand, this is the simulation of down counting, that means we are going down. But what we can do, we can choose a combination of both. Sometimes we are moving up, sometimes we are moving down. And it is not necessary that we have to start the counting up or down only at the first or last count. If we are at 10, we are moving up, we can start going down. And after 10, 9 will come. Then we are going down, 9, 8, 7, 6, 5. And then we can start moving up, 5, 6, 7, 8, 9, 10. So everything can be done in these type of counters. So now we have a good idea about the working principle of these counters. Let us code them in Verilog. So we have a very simple code. I have a module whose name is count for bit up down. Inputs are clock, reset, direction, and count is the output. So accordingly we have defined them that inputs are these three, output is only one, and output is a register. Then we say always at the rate positive edge of the clock or the positive edge of the reset. There are two control signals, one is reset, one is clock. First priority, the highest priority is for the reset. We say if reset, in that case count is set to 0. Now we consider the case when reset is 0, that means the else condition, and we say if direction is 0, in that case we are deciding to move up. So first thing that we have to take as a precaution, that if my current count by any chance is 15, then move it to 0. Otherwise keep counting up. Count is equal to count plus 1. Else means when the direction is 1. In this case we are going to count down. So the first thing that we have to make sure that if my present count is 0, then the next count should be 15. Otherwise, the count value will be count minus 1. So this is the simple code that we have, and now we are going to check the simulation for the same. The simulations are ready. So initially what we have done, we have kept reset equal to 1. So independent of the value of direction, the output count is 0. And then we change the reset to 0. Now we can count. So direction value is 0. Okay. So when the direction is 0, we are supposed to count up. So 0, 1, 2, 3, 4, 5, 6, 8, 9, 10. And here we have changed the direction to 1. That means now we should start counting down at this positive edge of the clock. So 10 becomes 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then 15, 14. Till this point we were counting down. Now we have again changed the direction to 0. That means at the next positive edge we will start counting up. So 14 becomes 15. Okay, then 0, 1, 2, 3, and we will keep counting up and we will continue. So this counter is working in both the directions. So students, now we have seen up, down and up down counters. Let us talk about a special counter in our next video, and that is Johnson counter and ring counter. Keep learning. Thank you.